All right, it's 2:21 and our next speaker is Martin Golasowski.
Yeah, Golasowski.
Golasowski.
It's Polish. I get it.
All right.
It's complicated.
He's the first of two speakers, and he's going to be talking about iRODS as a data backend for the Lexis workflow orchestration platform. All right.
Yeah, thank you very much. So I'm Martin. I'm a researcher at IT4I, which is the National Supercomputing Center of the Czech Republic. And together with my colleague, Mohamad from Munich, from Leibniz Research Center, we'll tell you something about the Lexis platform and how we use iRODS inside and how we progressed from our last talk here. I think it was like 2 years ago, 1 year ago, and how far we progressed. So yeah, I'll try to switch. Okay. So quick outline, first some introduction about the Lexis platform, how far we got with the project, where we are at the moment. Then something about what we call a Lexis distributed data infrastructure, which is the place where we use iRODS. Then how we work with OpenID, how we implemented the ACL for the APIs and so on. Then Mohamad will take over and will tell you something about the staging API, how we automated the testing of those APIs of the whole solution, and some other tests and some next steps. So something about the Lexis itself. So it was conceived as a technical concept in 2018. It was submitted as a proposal to Horizon 2020 program. It was actually funded. It was coordinated by us, by IT4I, by Dr. Martinovic, and the total budget was around 14 million euro, with 17 members from all over the Europe and from various types of industries and universities and so on. The project was for 3 years and ended in 2022 with a successful final review. And right now we are entering the sustainability phase of the project with some former members of the Lexis project consortium. Right now we have also onboarded a company, Uraccent, which now focuses on basically making the platform available for commercial uses. And this is those slides are part of some market study prepared by our colleague Mark Derken. And the Lexis platform is basically focusing on providing access to HPC and cloud resources to SMEs, research partners, and all other uses without the need to get a very expensive skill on how to access the clusters, work with modules, SSH, and so on, work with the cloud APIs, and so on. What we would like to provide is this essential execute button in a web browser, and things will happen. So this is our take on the digital sovereignty for Europe. We are also collaborating with, or we are aware of initiatives like GaiaX and so on. And we are still in talks with all the other groups which are involved in this push for digital sovereignty in Europe. So the key, so this was the political side of our talk. Now becomes the technical part. The key points of the Lexis platform is that the assumption is that there is a user which has a workflow described by a DAG, by some graph, which can consist of tasks which can run on cloud. It can launch services in a Kubernetes cluster. It can run jobs on HPC clusters, even on multiple HPC clusters in different centers within single workflow. And the user needs a data to run the workflow with, and he needs to store the results somewhere. So our idea to create is to create a platform which will expose a single common API to access all those different resources, HPC clusters, cloud, on-premises cloud, and also commercial cloud providers if necessary. And we also are, apart from the execution of workflow, we also take care of handling the federation of the data, of movement of the data between different centers, replicating them, and also publishing them with some traceability, with some IDs and so on. So you can see how the overall architecture of the platform looks like. Those big boxes here are two HPC centers, our HPC center IT4I and the LRZ center in Munich. Each center has its own HPC cluster and the on-premises cloud. And we have also bunch of other centers which are providing only storage resources to the platform. And the entire platform is connected by, guess what, iRODS, by a federation, by quite a big federation of dedicated iCAD servers. For that, and the entire platform shares a common AI infrastructure based on Keycloak. So just quickly about the orchestration. For orchestration, we are using Istia Orchestrator, which is a solution developed by ATOS, and we are using Tosca standard to describe the workflows and to launch the workflows on HPC clusters, which are operated under different identities, which is most of the academical HPC clusters, and of course the commercial HPC clusters out there. We are using something called Hippie middleware, which is our own service, which exposes the REST API for batch scheduler, and also kind of divides different authentication domains. So this is something what we do on the orchestration side. And in terms of the architecture of the entire platform, itself, it has been developed as a microservice-based platform with the zero trust architecture for communication between the different microservices. And for that, we are using JWT tokens. All of the microservices have REST APIs, and if you want to call the REST API of the service, you have to supply a valid JWT token issued by the Keycloak, which is basically the implementation of the OpenID identity provider. About the data, so how we actually use the iRODS in the Lexis is that we use it to establish basically a common common infrastructure to transfer, copy, and move data between different locations. This is an example of the two centers connected to each other. We have deployed iRODS, dedicated iRODS server in LRZ and dedicated iRODS server in IT4I. We have federated them together. And in order to transfer the data from iRODS to iRODS to the cloud instance, to some HPC cluster like by SSH and so on, or some dedicated bare metal server, we have built this bunch of REST APIs, REST-based services. And Mohamad will tell you more about them. And also those REST services are using the OpenID tokens. And this is something that we have also deployed here because the iRODS itself has to accept the identity of the Lexis platform user, which is described by the token issued by the Keycloak. And so we are using the standard federation mechanism between two iRODS zones to transfer the data. The idea is that each center, each physical center, which is included in the platform as a node, which provides some resources, deploys its own zone. And if someone wants to replicate the data with some traceability, and or also publish the data to some public indexes and so on, we are using technologies and software developed mainly by UDAT. So those are the infamous B2 services. So we are relying heavily on that as well. And this is just quickly how we, there's the screenshot that's missing here, but never mind. We are using the iRODS we basically have a bunch of root level folders, root level collections in each zone. And you can see that there are different collections for project level data sets, public data sets, and the user data sets per project, because the platform is organized to organizations, and an organization can have different computational projects to which the computational resources are consumed. And you can see here that we are hashing for example, the names of the project. So in case there is some data leak, we don't expose any names which can suggest some knowledge, know-how in the projects. And we are using, there is like one last level of in the zone is the dataset UID. So each dataset is its own collection described by an UID and a bunch of metadata within iRODS. So right now, something about how we use the OpenID. We used OpenID implementation for iRODS, which is based on this authentication microservice, which is a broker which directly communicates with the keycloak. And we are using an OpenID plugin, which is not the official part of the iRODS distribution. And we had to tweak it a little bit. And we also had to tweak the Python iRODS client in order to support this change. And it seems that after the talk, after we listened to the talk, which was before us, it seems that this solution is obsolete. And we would like to move forward with the PAM module and do it the official way. Anyway, if you want to check it out, how we actually implemented it, there are some links to the GitHub. But it seems that we'll move to the 4.3.0 quite soon. Therefore, we can use the PAM with the large tokens which we use inside the platform. Now, something about how we handle the access control. So, as I said, we are operating the keycloak instance, which is for the entire platform, and we have a bunch of groups there, which describes different access levels for data sets for the individual users. And in order to do that, in order to map this to the iRODS permission model, we have this sync script, which periodically pulls the list of users and projects from the keycloak instance and synchronizes the iRODS iCAD servers like periodically using some locally stored administrative level credentials, basically. So the idea is that if each center deploys its own iCAD server, they also have to deploy a sync script next to each other, or even on that same machine which runs the iCAD server. They have to create this admin credentials, put them inside the script configuration, but the script is called by a scheduler, and the credentials doesn't leave the premises of doesn't leave the boundary of the VM. They are not sent anywhere. The only thing which is basically pulled from outside is the list of the users and projects from the keycloak. And now I would like to pass the word to Mohamad, which will describe you the staging APIs and how we work with the Celery.
Yeah, good. Hello, everyone. I will be talking about the staging API. So the staging API allows us to move data from one source to a destination. And the API is a RESTful API. And since the data could be of a huge size, we needed to have an asynchronous API. And for that, we are using a Celery and a RabbitMQ to move the data between the centers. And as you can see in this diagram, we have a Celery worker deployed at each of the center. And based on the source target combination, the API will send the task to a specific queue. And here, for example, we have 10 different staging classes. And based on the type of the source and the target, the task is pushed to a specific task. And also based on the location of the source and the target, the task will be pushed to a certain queue. So for example, in the first case, if we are moving from iRODS to any local cloud or staging area, the task is pushed to the local queue. And if the target is the remote one, then the task is pushed to the remote queue. And in some cases, like cases 8, 9, 10, when we are moving from a local cloud, for example, to a remote HPC, the first task is executed locally, where we move the data from the cloud to the iRODS. We use iRODS as a staging area. And then the second task is pushed to the remote queue, where the data goes through the federation to the HPC resource. For the automated robots test, we wanted to test our system to see if we have any errors at any point and get a report that, okay, there's something wrong happening in our system. And for that, we used the Python and robot framework. And we run tests every 10 or 20 minutes on our system to check if everything is okay. These tests include the local ICAT test, basically obtain a password and an OpenID token and try to transfer a file. This is a very simple test. We do also a federation test. We try to copy a file to the federated zone to see if the federation is up and working. We also do an authentication test to test that the OpenID provider is working well. We also test our API to make sure the APIs are running, and we test our handle system to make sure that our PID provider is still running. And after all these tests are executed, an HTML report is generated, and we can see the result. And in case of an error, we have a Mattermost channel is Slack based, and we get a message on our Slack bot that a test has failed, and we need to do some actions. And this is an example of how the report look like. If the tests are all passing, then you see all is green. If it's failed, we see all red. And on the right side, you see our Mattermost chat. You see that it's a test failed, and it gives a link to the log. You can open the log, and then you can check, okay, what's happening, and then try to fix that. One more thing is the speed measurement. So since the orchestrator is connected to the dynamic allocation module, which chooses which resources will be allocated to the workflow, we need to know the penalty of transferring the data to the HPC or the cloud instance to run the workflow. And for that, we wanted to do some tests to see how iRODS does with the speed test. And for that, we did a simple iRODS to iRODS test via ICP, via B2Save. I put via the Python client. And for example, we got these results. As you can see, when we are dealing with small files, it's very slow. When we go up to a bigger data sets, it's very good performance. And for that, we decided to implement a compression API so that we can compress all the small files together on a very huge machine. Sometimes it takes a couple of seconds or a minute for 100 gigabyte data set to compress. So yeah, the performance is quite good compared to just transferring the files alone. And yeah, an outlook for the future, we will try to sustain the platform for commercial use. We want to extend the staging API to not only support the classical cloud and HPC resources, maybe for object storage. We are very interested in upgrading to 4.3.0 at some point. And we want to prepare a deployment via Docker for all our components to make it easy for other institutions or commercial companies to federate with us and join our federation. And thank you very much. We're happy to answer your questions.
All right.